Example 2 is with spheres. I underlined the word sphere and I drew a sphere, or I put in a sphere picture just so you have a visual of what's going on here. It is a spherical balloon, so it's a circular balloon here being inflated such that the rate of change in radius is 2 millimeters per second. So that just means we have a rate of change, which is a derivative. It is getting bigger. This radius is getting bigger with changing 2 millimeters per second. So if I'm going to do my given and my find, my given is the 2, and that is a rate of change of radius. So I'd write that as dr dt because it's rate of change, it's the changing of the radius, and dt because it's changing with respect to time, and it's 2 millimeters per second. If it's increasing up, then it would be 2, or positive 2. What is the rate of change of the surface area? Okay, so that's my find. Rate of change of the surface area is what I need to find, so I'm going to call that dSA dt, derivative of surface area, with respect to time. When, okay, and we don't know that. When the radius is 8, so radius is 8. So I need to, write down what I'm given, what I have to find, and then, let's see, I need to write an equation that involves surface area and radius. So this formula for surface area of a cylinder, if you don't know it, you got to look it up. And I haven't looked at that in a year. I don't want to get it wrong. Surface area of cylinder is, I'm saying cylinder and I mean sphere. All right, so surface area of a sphere is, 4 pi r squared. So surface area of a sphere, 4 pi r squared, so that is my step 2. I write an equation and it has surface area in it and it has a radius in it. So I know I'm on the right track with this formula. Then I do the derivative of both sides. The derivative of a variable SA is just 1 times d SA dt. Then this is not a product rule because it only has one variable, r. So I can do the power rule to do the derivative. I'll just bring the 2 down in front, so it'd be 8 pi r. And then I did the derivative of something with an r in it, so dr dt. Next, I'll plug stuff in, so I don't really need the 1. So dSA dt, that's what I'm finding. So that will just stay. And then 8 pi, r is over here, it's 8. And then dr dt was 2. So once you, do your derivative on both sides, what you should be able to do is plug in, for everything except the thing you're trying to find. So I did that. So I'm going to leave it in terms of pi again. It's just neater. So 8 times 8 is 64, times 2 is 128, so it'd be 128 pi. Surface area is an area, it's 2-dimensional, and since I'm working in millimeters, I would say millimeters squared per second. And again, that's using millimeters up here and second, and then doing millimeters squared because area has 2 dimensions.